We continue our discussion of vectors, now looking at the fact that it was easy to add vectors in Cartesian representation. What about if you had to take a vector in Cartesian representation and multiply it by a scalar? Well, it turns out it's easy to do that as well. All you need to do is just distribute the multiplication of the scalar onto each of the vector's components, just like you would do in algebra class. So, for instance, in algebra, you probably had something like this sometime during thing, like a plus x plus y. And what you would do is just say that, well, that's ax, where you distributed the a onto the x, and then you distributed the a onto the y. So it's plus ay. Well, that's exactly what you do. The only thing different is that these are going to be a component with an I hat, and this is going to have the y component and a j hat. But otherwise, it's just like a times x plus a times y. You just distribute. So as an example, here's our vector, 3 meters I hat minus 4 meters j hat, and we want, for instance, to multiply by the scalar 3 kilograms. Alright, so that's 3 kilograms times 3 meters I hat minus 4 meters j hat. So I now distribute 3 kilograms times 3 meters is 9 kilogram meter I hat, and 3 kilograms times minus 4 meters is minus 12 kilogram meters j hat. The overall vector got 3 times as long. It was originally something like this. That was A. And now the vector is a new vector, 4 times as long. But it's more than just that. I'm sorry, not 4 times long, 3 times as long as what A was, but it's more than that. It's also a new quantity because it has a new unit. It's a kilogram meter, not just a meter anymore. So it's changed physically what it was and made it 3 times longer. Did not change the direction. Direction stays the same, just as it did in polar form. But the difference is that the way we looked at it, this was supposedly 3 meters. Now this thing is going out for a total of 9 kilogram meters. 3 times further along the x, and it was just going down a little bit, minus 4 meters. And now if I've done this right, this is now going down a total of minus 12 kilogram meters. So it makes each one of the coordinates here 3 times longer. 3 times more x, 3 times more y, makes the total 3 times longer here along the hypotenuse. Easy to do. Let's take another one. Now we're going to multiply by a minus 2. So minus 2, and if I remember right, I had 3 meters I hat minus 4 meters j hat. So minus 2a is minus 2 times 3, minus 6 meters I hat. Minus 2 times minus 4 is plus 8 meters j hat. So again, we had, just a second, let me create us a little coordinate system here. And we originally had this vector that was over here. That was our A. And what this did is it made it 2 times longer. Now it's going to go out 6 units over here and 8 units up here, so it's over there. And in fact, if I've drawn it to scale, it's, oops, sorry about that. It's pointing 180 degrees out of the way, and it's 2 times as long. So whether it's in polar form or whether it's in Cartesian form, it is always easy to multiply a vector by a scalar. If the vector is a negative scalar, it will rotate 180 degrees. So it changes the direction, and because the absolute value was 2, it makes it twice as long as the original vector. Okay? All right, that's it for this section.